Alright folks, so now what we're going to talk about is the topic of scope. So I keep alluding that it's not about mouthwash, so we got to figure out what it's about. Scope. So a good definition of scope is the range of statements a variable is visible to. Alright, so you know that in some blocks of code a variable is visible, and then in other blocks of code that same variable may not be visible. So there's two flavors of scope. There's static and dynamics. So in static scope, the variable visibility, the range of statements that a variable is visible to, is predetermined at compile time. And in dynamic, the range of statements a variable is visible to is determined at runtime. So I think when I explain dynamic to you, you're going to say, what? Because you've probably never seen anything like it before. It is a little weird, but there are languages that use dynamic scoping. So first, let's take a look at static scoping. And I'm going to give you some code in Ada. And the most effective way to get this to work is I want you to write this code down in Ada in your notes, have it ready, and then I'm going to jump out of the writing that I'm doing and show you some visualizations of this code, or of some other pieces of code. Okay, so we're going to define a procedure, which is a lot like a method. Procedure big is, and then inside big we're going to find x as an integer, and then within procedure big we're going to declare a procedure subprogram, procedure subprogram 1 is, and we're going to have a begin that starts a block of code, and somewhere in this begin there's going to be a statement that says x equals 55, and then we're going to have an end, semicolon, and that takes care of this procedure. And then we're also going to have procedure sub 2, and we're going to have a begin. Oops, sorry about that. Before we have the begin, we're going to have an x colon integer. So we're declaring another integer. Then we're going to say begin. And in here, I'm going to say x equals 42. And then I have an end, semicolon. I'm not done yet. Just going to bring this up just a little bit. And I'm going to have a main method, or not a main method, but the block of code that's associated with procedure big. So I've declared two subprograms within big. I'm going to declare now a begin, and I'm going to say x equals 97, and then end. Alright, now got this whole thing written here. And what I'd like to do is I'd like to answer the question, well, I'd like to say that when the compiler compiles this chunk of code, right, from the beginning of procedure big, the two subprograms, and then the chunk of code that's the main block of code for procedure big. When that all gets compiled, the compiler creates something called a scope tree. And the scope tree looks like this. You got big, you got sub 1, and you got sub 2. And basically what we're saying here is if I'm in sub 1, then the variables that I have access to, the variables that I can see, are variables that are in sub 1 and also in big. If I'm in sub 2, the variables I can see are the variables that are in sub 2 and also in big. So question number, given that's true, my first question is this. What is the x referenced in sub 1? Where's that x located? I'm going to just hold this so you can see it all in one place. I'm not sure how to zoom out with this yet, so I'm just holding it all in place. So where's the x? Who owns, what subroutine owns the x that is referenced in sub 1? Alright, and the answer to that is big. It's bigs. If we scroll down for just a second here, sub 1 doesn't declare an x, so since the x isn't there, we're going to move up the scope tree and look in big and see if we can find an x there, which we do. Alright, so 2, what's the x that's referenced in sub 2? Alright, in this situation, we're going to look at the variables that are declared in sub 2 first and see, oh yeah, there's an x declared there. So we're going to use the x that's declared in sub 2. If there wasn't an x declared there, we'd move up the scope tree to look at the x declared in big. Okay. Now, what I want to do is look at a more complex example. And the way we're going to do this is I'm going to say, take a look at, if you go on the course website and you look at the section of the course notes that relate to the section of the course notes that relate to names, bindings, type checking, scope, you can download the notes that I have right here. Now, this is actually the reverse order that I wanted to show it to you. So let's do this. Let me drag. Oh, see if I can do this. Grab this. Ah, whatever. Okay. Oh, it's letting me do it. This is taking a little bit of time because I'm really pounding the machine. All right. Bring that over here. Good. All right. So imagine that I have a set of routine procedures and then subprograms or subroutines within those procedures. Right? So I have a procedure called main. It has a begin and end. But within main, I've got another procedure called A. And then within A, I've got another procedure called C and another procedure called D. And then inside main, I have another procedure called B. And within B, I have a procedure called E. And inside B, I declare x as an integer. And then inside E, I say x equals 5. Pretty exciting, okay? So there's a lot of nested subprograms here. And I have a variable declaration in B and also an x equals 5 here. All right. So that's the structure of the subprograms within my program. Then over here, what I have is something that's called a call graph. The call graph represents the possible ways that subroutines can refer to other subroutines, or subprograms can refer to other subprograms within the program. So main can call A, or main can call B. All right, that makes sense. If you look over here, A is declared as a subprogram of main, and B is declared as a subprogram of main. A can call B because they have the same scope. A can say, hey main, tell me about subprograms you know about, and main can say, oh, I know about B. So A can call B, and B can call A. So you can see this arrow here between A and B. A can call itself, or it can call C or D. Once C is done, well, inside C, C can call A again, or C can call itself. And although C and D have the same scope, the way the call graph's written shows that it's possible for D to call C, but C will never call D. Now, scope-wise, there shouldn't be a problem with C calling D, but we're going to pretend the way the code's written that D potentially can call C, but C will never call D. And then over here, on the right, we see B can call itself or A, and B can also call E. E can call itself or B, and also, interestingly, E can call A. Now, you might be saying to yourself, how is that possible? Does E know about A? Well, if you think about the scope tree, right? If I were to actually draw the scope tree for this program, the scope tree would look like this. Get over here, and let's see if I can take advantage of all the screen space I have here. I'm going to drag this. Oops, dragged it a little bit too far. Okay, great. That's there. And I'm going to drag this over here. See if I can get that to work. It's running really slow. Okay, come on. I'd like to show these side by side. There we go. This is a really awesome Mac that I have too, so the fact that it's struggling means I'm really making it do a lot to do this video recording. Right, I'm going to drag this back over here. Okay, actually that's fine. So let me zoom down here, and I'll take my little screen recording guy and put that over here. This must be really exciting for you, watching me move this stuff around. Okay, good enough. I'll take that. All right, so let's design the scope tree for this. So we've got main, and main can call A, which can call B, or main has a subprogram A inside it and a subprogram B inside it. A has a subprogram C inside it, and D, and B has a subprogram E inside it. All right, so if you think about it, if E wants to call A, that's certainly possible, because even though we're not talking about types here, E is going to look to B for information, and if B doesn't contain the information, it's going to look at main for information, and main is going to know about A. So let me rephrase that. If E wants to make a call to the subprogram A, and E says, well, I don't know, I don't have a subprogram A. B, do you have a subprogram A? B goes, nope, but check main. And so main goes, yeah, I do have a subprogram A. You can call that. All right. So now I have some questions. Is the following, and these questions relate to, do you understand? So this is the scope tree. Let me write that first. Scope tree. Great. All right. And now what I want to do is I want to drag this over for a second and ask you this question, given that you can see the call graph there. So is the following call sequence valid? All right. Main calls B, calls D, calls E. Is that valid? So if you look at the call graph, you can see that it's not valid, because it's possible for main to call B, and it's possible, but once you're at B, you can't get to D directly. So this is not valid. How about this? Main calls B, calls E, calls E, calls B, calls E. Is that valid? So the answer to this is yes. Main can call B, B can call E, E can call itself, and then it can call B, and B can then call E again. So this is okay. So if we're at the third call to E, this E, and we refer to X, we now have an assignment statement like X equals 5. All right. So let me go over here. So we've got that statement, X equals 5. And this is the third call to E. Where is that X located? And the answer to that is that it's located right here. It was declared in that particular invocation of the subprogram B. So we have two invocations of the subprogram B. The first one directly from main. The second one occurs when the second E calls B. That's the X that we're going to use when we refer to it in the third call to E. Whew. All right. And the second call to E, this E, if it refers to an X, it is going to refer to the first call to B's X. All right, well, hopefully that makes sense. Now, let's see. I had a little question here I wanted to ask you. Oh, I'm just wondering if, oh, so here's a question. Is it possible for E to access the variables that are within D's scope? All right, and so let me just repeat that question. Is it possible, if a variable is declared in the subprogram D, is it possible for E to access those variables? So the answer to that is no. You can't access D's variables. If you look at the scope tree, with scope trees you can go up. All right, so the scope of variables that E has access to are the variables from here up to here. We can't go back down, and you're not allowed to do that with a scope tree. So how could we access the variables in D's scope? Well, there's no real clean way of doing it the way the code is currently structured. You know, maybe you could pull E into D, so E is now a subprogram of D. That might be one way of handling it. But that maybe you could pull all the variables that were in D and pull them out and make them variables of the main program. But the reality is that only D cares about it. Actually, only D and E care about it. So that might make things a little bit messy. So there really isn't a clean way of doing it. And in fact, this points to one of the problems with the subprogram approach, which is sometimes you get into situations where you have a subprogram very, very deep in one branch of the scope tree and a subprogram buried very deep in another branch of the subtree, and they need to access each other's variables, and it just turns into a mess to correct that. So the way one of the ways Java solves this kind of problem is by just having basically by flattening the scope tree. You have a class, and the class has members and methods. All right, and so then they all have the same. The scope tree has no depth to it, so it's you have. I mean, this is kind of a little weird, but I think it's okay. We'll just say I'll do it this way. So I'll say class, and this is A, B, C, D, E. All right, and so there can be some local variables within A, but any variables that you want to share between A and any other method are going to be declared as members of the class. So that's what the scope tree would look like in Java. Java also allows for inner classes, but personally, in my opinion, they just mess everything up, and you can end up in this kind of scope tree nightmare scenario. So I think it's much better to just keep things simple and deal with just class members at the highest level of the scope tree, and then local variables inside methods one level down. All right, so that takes care of the discussion of static scoping. The next thing I'm going to talk about is dynamic scoping, but that'll be in the next video.